yours was better. Next up, we have Tania Vincent from Alaska Department of Fish and Game to talk star search, intertidal monitoring at Ellamar Spit. Hi, Tania. Come on up.
All right, we're on here. Okay, yeah. So, as you saw in your program, I work for Alaska Department of Fish and Game, but what I'm going to talk to you about today has absolutely nothing to do with them. I have alter ego. One of my alter egos is intertidal ecologist. So today I will be talking about some of the results from. Here we go. See here. Yeah, some of the results from my annual intertidal monitoring that I've been conducting at Ellamar Spit and at a reef on nearby Busby Island since 2004. I will also be discussing some of the results that I have with respect to buoy number 46060. So you can see on the map there, sort of orient you to where these things are taking place. Now, to give context to the intertidal site at Ellamar Spit and nearby Busby Reef, it's important to acknowledge the fact that it is deeply steeped in human history. And according to Chugach Corp. And Titlik Corporation, the Ellamar area has had at least 5,000 years of human occupation and use, with multiple village sites. And descendants of these people now live in Titlik. However, the Ellamar area, where my intertidal site is, has descent, or the people were living, Titlik people were living there until 1897. And what happened in 1897 was that two mining prospectors filed a mining patent that forced the Titlik people to move south to the village's current location. And then in 1898 to 1929, copper was mined and shipped out of Ellamar. It was this big happening town. But then after 1929, when the mine shut down, a new venture started up, which was fish canning. And people lived and worked there at Ellamar until the 1960s, when the facilities burned down. So the population after that sort of declined to the point of being mostly seasonal inhabitants, with a few exceptions, who either fixed up old mining cabins or built new ones. And sort of all of this is to say that the rocky intertidal habitat of Ellamar Spit has certainly been trod upon and used for that entire history. Well, what has it been used for? Most coastal peoples, and we saw this yesterday, most coastal peoples have a version of this saying, when the tide goes out, the table is set. And that's actually what brought me to Ellamar over 2 decades ago. I was part of a team that was studying the giant Pacific octopuses in Prince William Sound and Ketchikan Bay, actually 10 years prior to that. And in consultation with Titlik elder Jerry Totemoff, he informed us that people from Titlik regularly went to the Spit to hunt for octopuses. So we went to the Spit hoping to find some ourselves, and indeed we did. And here is a tide pool octopus that was on the Spit. And I've seen many, many more since then, but that's an example. So as part of the team, I first surveyed Ellamar Spit in June 2004 to estimate the densities of octopus prey species, which is essentially the various intertidal benthic fauna that we found in the intertidal octopus dens. But starting in 2005, with the idea that we would be returning to the site repeatedly, I began recording not just octopus prey species, but all of the non-encrusting benthic fauna that I could find in meter square plots along the intertidal zone. And so year after year, I followed the same methods of recording both habitat characteristics of these meter square plots and the sizes and identities of fauna that I found within them. And since 2005, the only year that I did not survey Ellamar Spit at the lowest low June tide was 2020. I just want to say the surveys were consistently done at the lowest low tides in June, which is the tide that exposes the zone in which octopuses are in. So that's the zone that I've been interested in. All of this gives a really interesting snapshot over time. Meanwhile, over those 2 decades that I've been doing surveys, buoy 46060 has been recording sea surface temperatures nearby. And during that period that I have been doing my studies, 2 major events occurred which could potentially impact the natural history of Ellamar Spit. The first is the 2 major Northeast Pacific-wide marine heat wave events that occurred sort of jointly 2015 to 2016 and then again in 2019. And then the second event was the advent of the Seastar wasting disease. Now, it turns out that the mean January sea surface temperature of buoy 46060 is highly correlated with measurements from intertidal temperature loggers that were placed in intertidal sites by other studies that have been done in Prince William Sound during 2008 to 2020. So their hot times and my hot time, or the buoy's hot times and their cold times match up. And if you want to go back in time to the 1996 when the buoy sort of started recording, that matches up really well with the Gulf of Alaska. There's a series of buoys that stretch out from Seward that's called GAC, the Gulf of Alaska buoys that measure temperatures, and everything correlates. So we can say with pretty high confidence that the period before I began my Ellamar surveys was a warm period, and then after I started them was a cold period, and then 2015 and 2016 it shot up to the warmest period that buoy has ever seen. And then sort of at 2020 to present, you can see the temperature has dropped off a bit, but it's still within that warm range that occurred in prior times. So it's also during the first marine heat wave that Seastar wasting disease first showed up in Prince William Sound. In 2015 at one of our octopus research locations on Green Island. It did not show up at Ellamar in my sites until 2016. Now, Seastar wasting disease was actually documented in California in a seastar called Heliaster well over 30 years ago. It's caused by a densovirus, which causes a series of symptoms, which sort of going in increasing order starts with lethargy and curling of limbs. And you can see that in the first picture there. That that's a picture of Pisaster. And you can see its limbs that are curled over there. And then sort of the second degree is having lesions, and you can see that in the second picture. That's a picture of Pycnopodia, who I'll be talking about later. And it's got 2 lesions on the arms there. And then as the disease worsens, they can lose arms and they lose turgor. Now, sea stars are basically filled with water. Their structure, their skeleton, what holds them up is water, just like plants. And so they have turgor pressure that keeps them nice, big, and fat. And so this disease can actually cause them to lose turgor, and then eventually they die. So after the outbreaks in 1978 and 82, it shows up in the Heliaster. It actually shows up again in California in Pisaster and 9 other species. And then during 2013 to 2015, this showed up again in California, but it stretched all the way up to Alaska. And this event is considered, and I quote, the largest marine epizootic event yet observed. So Seastar wasting disease was recorded in 20 different kinds of sea stars during this event. Now, at Ellamar Spit, there are 3 kinds of sea stars that consistently show up in my intertidal monitoring plots, as you recall, the lower low tide plots. And then there's one species that occurs higher up in a shallower zone that I actually do see as I'm walking down to the lower zones. So only 2 of these sea stars have ever shown signs of sea star wasting disease at Ellamar, or that I have seen. And one is Pisaster, and that's up there, and then the other is Pycnopodia. Now, Pycnopodia is that its common name is the sunflower star, though if my then 3-year-old daughter could call them Pycnopodia, you certainly can too. It commonly occurred in my intertidal sites. I mean, really commonly occurred in my intertidal sites. But it is generally a subtidal species to low intertidal species. So you'll see these subtidally when you're diving, and then you'll see them in the low intertidal where you're searching for octopuses. The species is the largest, heaviest, and most active sea star on the west coast of North America. Now, prior to 2016, we saw Pycnopodias everywhere, and they could even be caught on longline. But then in 2016, only 1 Pycnopodia was recorded in the Ellamar and Busby plots, and it was this little tiny recruit. And that's when I decided that I needed to add a sea star component to my study. So starting in 2017, I began with a Seastar focused surveys to get greater samples of species size and disease composition. So we can now ask the question, what has happened since 2016, and how does that relate to what came before? So I can look at my data, and habitat did sort of change over that whole time series that I have. I have percent cover of kelp. We learned about the types of kelps that are in Prince William Sound earlier this morning. And we can see that there is kind of a pattern here. The kelps in general seem to do well during the cold period that occurred, and then dived down to very low percent cover during the marine heat waves. And then you'll see some recovery, 22 and 24, I think it is, that it goes back up again, even though the temperature is still fairly warm. On the other hand, if you look at the percent cover of eelgrass in my plots, it doesn't seem to care about temperature at all. So if we look at Pycnopodia, which is now I've matched, so you can see the brown is the percent cover of kelp in my plots over time, and the orange or yellow is actually the density of Pycnopodia over time. It very much declines sharply in 2016, so we see that. But then it starts to recover in 2022, and then again in 2024. And then there's two other things to notice about this. One is the strong convergence with kelp cover, and then the very disappointing crash again last year in 2025. If we look at the other really common Seastar in my plots, which is Dermasterius, what's also called a leather star. So here we have brown again as the kelp cover, and then Dermasterius it was less density than the Pycnopodias, but fairly constant until you get to the last few years, and then you see a big dramatic increase, and the population has taken off. So the interesting thing is, so I've got on the bottom is the plots that I did. So these are all the plots back to 2004. And then you see up on the top graph, the Seastar surveys that I did. And if you look at, so the blue is the density of Pycnopodia, and the orange is density of Dermasterius. You can see the shift from Pycnopodia dominated to Dermasterius dominated over that time period. And the reason I show both of those is because they're sort of two independent samples, and because the latter part matches up really well, I'm fairly confident that it's not just a fluke that this change is happening, but that if you go back in time, you would have seen that as well. So although Seastar wasting disease was visible in Pycnopodia every year since 2016, the prevalence of the symptoms were actually not that great, because if you look on the left graph, this is in the Seastar surveys. So I have lots of Seastars measured. Most of them don't show symptoms. That's the white. And then the little colored bits at the top are ones that showed symptoms. Well, if you look on the right graph, those are all of the Seastars that showed symptoms. Early on, they seem to be pretty severe, which is orange. And then the blue is sort of the milder symptoms. You start to see more and more Seastars with mild symptoms later on. So this is also interesting too, that came out of the Seastar surveys. On the bottoms of the year of the Seastar surveys, and then going up is the size of the Seastars. And you can basically, that yellow line there based on information in the literature is 5 centimeter size. Anything below 5 centimeters size, we can probably say settled out that year. So these are the recruitments, and then everything else is older, and then the bigger they are, the older they are. So one thing to notice is as the blobs get bigger, that's bigger populations. So you can see the increase in Pycnopodia in 2022, and then in 2024, that population was pretty big that I measured. But one thing to notice is that in 2022, that blob is fairly small. So it's those like 10 centimeters, 15 centimeters and below. These were young animals. So that 2016, these guys have recruited since that 2016. They're trying to come back into the population. And then in 2024, you can see that the distribution of sizes has spread out. And on the other hand, it's still, you might consider it small size weighted, especially when we compare it to the blobs that Dermasterius makes. So over time, as Dermasterius has increased, we saw it strongly increase over time. The blobs get thicker. But the other thing to notice is that they basically have a little normal distribution of size. So there's not very many small, not very large, but most of them are sort of mid-size. And that sort of shows a population that is not been impacted by Seastar wasting disease and knockdown and everything. So one thing that we might wonder is, what is going to happen because of this shift between Pycnopodia to Dermasterius? We know from studies on the West Coast that Pisaster, remember Pisaster, that's the Seastar higher up, it can actually, if you remove Pisaster from the community, you can change the whole ecology of the area. You can go from a very diverse system to just basically one species left. And so that is my big question. What are the implications of the shift between Pycnopodia-dominated community to a Dermasterius-dominated community? So as I continue my next episode of Star Search, I'll be looking for the impacts of this shift. I have a whole slew of data I have not analyzed yet, so that is a big thing. But the last thing I want to do is, as we segue between sea stars and the next talk, which is inspired by a Prince William Sound inspired artist, I wanted to show you this. As you saw, my daughters have been involved in intertidal surveys since they were very little. And one of them is now studying to be a stop motion animator. And as you might expect, her early childhood experiences have influenced her art. So I would like to share her short sea monster movie with you. Now, sea monster movies typically have a shark or an octopus, but as you'll see, my daughter had different ideas. Now, I don't know if I can start this here. Does it? There we go. Whittier. That's the Seastar stomach coming out. She's daughter of a biologist. Yeah, okay, that's the end of the talk.
We have questions. We have time for one or two questions for Tania.
We have a question online.
Okay, great.
Did the octopuses suffer from the warm periods?
So I haven't strongly analyzed that data yet, but yes, I would say so. They did we were like tagging octopuses right and left during that cold period, and they definitely became less visible in the low intertidal where we're surveying. I did encounter dens. There was definitely the other thing that I think has shifted, and again, I need to analyze this data. This is just sort of looking at it grossly, but they've sort of shifted from eating a lot of crabs to going more towards the shellfish, I can't even bring up the names of the little shellfish that they eat. But yeah, I think there's been sort of a shift in diet as well as sort of a decline. But I really need to that's something that needs to be looked at in my data a little bit more seriously.
Time for one more brief question. I have one if no one else does, and so I was trying to track there, but you said that, oh yeah, thanks. Thanks, Ellen. So we just have a minute, but with a potentially strong El Nino coming, so, you know, I was listening, it sounds like your starfish, that's been one El Nino, right?
Right.
So you have another potentially stronger one. We only have a minute, but looks like you might be
So-
thinking something.
So yeah. I mean, I heard about, yes, the El Nino. I actually don't think so this project is at this point entirely self-funded. But it's I don't know, it's my passion project. So I am very excited to go out this year. And this year we're having an exceptionally great low tide series. I can get out to both Busby and Ellamar this year. But I suspect I'm not going to see anything. I don't know what I'm going to see with the Pycnopodia. That surprised me because I think people working in Ketchimek Bay did not see this huge drop, but I mean, there were no Pycnopodia. What's going to happen this year? This is very exciting for me. Like again, next episode of Star Search. I suspect what El Nino, from what I've read and other information, it really impacts the winter sea surface temperatures. That's where things get impacted. So we're not going to see it till not this summer, but next summer. I'm really worried about, well, what's going to happen. My ecologist, the environmentalist says, well, really worried, but the ecologist in me is like really excited.
Love the film too. Thank you, Tanya.